Assalamualaikum and hi everyone, I'm Nurdania Afrina Vitamiti, and today I'll be presenting my project is Differential Equation and its solution using mathematica. Okay, now we dive into how mathematical model in our reality situation and how we can solve it using mathematica.
Introduction. Differential equations are powerful mathematical tools that describe how things change over time. They are widely used in fields like physics, biology, economics, and engineering. In this project, I focus on a specific application, which is population growth modeling. And I also explore how to solve it using work from mathematica. Problem statement and literature review. The problem I explore is predicting population growth over time. In real life, resources are limited, so population don't grow indefinitely. The logistic growth model captures this behavior. The differential equation for logistic growth is dp over dt equal to rp times with 1 minus p over k, where p is the population, r is the growth rate, and k is the carrying capacity. This model was introduced by Pierre Verhulst in the 19th century. It improved upon the exponential model by considering environmental limits. It's commonly used in ecology, epidemiology, and economics.
Here's how I approach the problem. First, I selected the logistic growth model as the mathematical representation. Then I use work from mathematica to define the equation. Finally, visualize the results using graphing tools.
Computational solution using mathematica. This is the code I use in mathematica. First, I define the parameters. Growth rate R equal to 0.5. Carrying capacity K equal to 1000. And initial population P0 equal to 100. Then I wrote the differential equation and solve it using the dsolve function. Finally, I plot the solution over time using plot. As you can see, the graph shows an S-shaped curve. Population grows quickly at first, then slow down, and finally stabilize at the carrying capacity.
Okay, let's proceed to discussion. This solution reflects what happens in nature. When the population is small, growth is fast due to less competition. As the population increases, the resources become limited and growth slows down. Eventually, the population reaches a stable equilibrium. This example shows how differential equation help us understand the dynamic system and how the mathematical simplifies the solving and visualization process.
To conclude, the logistic growth model, a practical example of how differential equation can model real-world problems. Using mathematica, we can solve and visualize the equation efficiently. This project has deep by understanding of mathematical modeling and computational tools. Here are the references I use, including works by Verhulst, textbook on differential equations, and official mathematical documentation. Thank you for watching my presentation. I hope this gives you insight into how mathematics and software like Mathematica can be used to solve complex real-life problems. Assalamualaikum and goodbye.